Assalamu alaikum guys, welcome to my channel Electronic Devices Analysis. So guys, our today's topic is operational states of bipolar junction transistor. In this video we will see that in what condition bipolar junction transistor is operate. So guys, before I start our video, I would like to say you that please subscribe our channel and press on bell icon for more informative videos which I will upload in future. So guys, let's start. Guys, first of all, we see the operational states of bipolar junction transistor. There are three modes of operations where bipolar junction transistor is operate. The first one is cutoff mode, second one is saturation mode, and third one is active mode. In these modes, the bipolar junction transistor is operate efficiently. So guys, we learn them one by one. First of all, we study the cutoff mode of bipolar junction transistor. Here we see the first operational state of bipolar junction transistor. In this mode, we have to see that the base current of the transistor IB is equals to 0. When base current is equals to 0, we learn some formula that IC over IB is equals to beta. The beta is the amplification factor. The beta is the amplification factor, and beta is equals to IC over IB. IC is collector current where IB is the base current. So IC will be equals to beta times IB, which will be equals to beta into 0. So it will be 0. IC will be 0 in this state, which is called cutoff mode. As we have already known that the output characteristics of a transistor are drawn between the IC versus VCB or VCE in common emitter or common base configuration. When IC will be equals to 0, this mode of operation of the transistor is called cutoff mode. So for IC will be equals to 0, we'll learn some formula that VCE, the collector and emitter junction of the transistor, is VCC minus IC into RC. This is the formula which we will drive in common emitter configuration. Battery will supply VCC battery will supply voltage to the resistor, and when IC will be equals to 0, so this factor will becomes VCE will be equals to VCC. The collector emitter junction will be equals to the battery, which is called VCC. So guys, this is the cutoff mode of a transistor where collector emitter junction will be equals to VCC. The collector emitter junction is equals to VCC in common emitter configuration, while VCB is equal to VCC in common base configuration. So guys, now we study the second mode of operation of transistor, which is saturation region. So guys, here we study the second mode of operation of the transistor, which is saturation region. In this region, our collector emitter junction will be equals to 0 or approximately equals to 0. But in cutoff mode or in the cutoff region, we will see that the VCE will be equals to VCC. But in saturation region, our collector emitter junction is approximately equals to 0. So therefore, we will see that the VCC will not supply any voltage to the collector emitter junction. Therefore, the VCE will be equals to 0. And when VCE will be equals to 0, we learn formula of VCE. VCE will be equals to VCC minus IC into RC. When VCE will be equals to 0, this equation will become VCC minus IC into RC will be equals to 0. Here we drive IC because in output characteristics of the transistor, we will take IC on the y-axis. So IC will be equals to VCC over RC. This IC will be called IC saturation. In this saturation region, IC will be equals to VCC over RC. So guys, we on x-axis we will take VCE or VCB in output characteristics of the transistor. On y-axis we will take IC saturation. So guys, our both points are clear of saturation region and cutoff region. Now we will study the third mode of operation of bipolar junction transistor, which is called active region or linear region. Guys, the third mode of operation of the bipolar junction transistor is active region or the linear region. In this region, the equation IC is equals to beta times IB is correct or follow the transistor property. So IC will be equals to beta times IB is follows the active region or linear region. In this equation you will see that IC is directly proportional to IB. As IC or the collector current will be increases, our base current will be increases. So guys, we see that these are in linear region. The linear region will becomes when a graph will be plotted between IC and IB, we will take a straight line. And when straight line will be taken, this region of operation is called linear region. So guys, in this region of operation, IC will be increases, so IB will be increases. So this is called the active region or the linear region of the transistor. So guys, now we will see applications of the transistor in these regions. So guys, now we will see the applications of bipolar junction transistor. In applications, as we know that the transistor is used as an amplifier or as a switch. Amplifier is that if a small signal is present on the input, it will convert it to a large signal. This is called an amplifier, and switch is 1 0 or on off. This will be a switch. So guys, in these mode of operations, the cutoff mode, the saturation mode and the active mode, we see some applications of the transistor. In cutoff mode or in saturation mode, our transistor will be used as a switch, because we will see that in cutoff mode VCE will be equals to VCC. In saturation mode the VCE is approximately equals to 0. So this will becomes 1, this will become 0. So therefore our transistor is used as a switch in cutoff mode and in the saturation mode. But in the active region or in the linear region, in active or in linear region, we see that IC increases, so other factor IB will be increases. So therefore a small signal is converted into a large signal. So this region of operation, the active or the linear region, is used as an amplifier. So guys, these are the applications of our transistor in these mode of operations. So guys, that's all for today. If you like our video, press on like button. Allah Hafiz.